Okay, so now we should talk a little bit about static versus dynamic scoping and how these are implemented in subprogram activation. So static scoping is again what you're used to. It involves looking through the lexical scopes in order to to do name resolution for variables. And this is not too difficult in languages like C where you don't have nested subprograms because the only places that you have to look are they're either going to be local variables or they're going to be some sort of global variable. And so there are only two places to look, and you know where to look for local variables because they're an offset, a negative offset from the base pointer, as we saw in the previous video, and the global variables are stored at a fixed offset inside of the program's address space. So that's a fairly easy and straightforward situation. However, static scoping gets a lot harder when you have nested subprograms, and you have to be able to look through more than two of these scopes in order to find a variable. And so typically the method of implementing this for languages that need it is something called a static chain. So rather than just keeping a dynamic chain of dynamic pointers like we saw, you also keep a static chain where you have a bunch of static links. And it's very similar to dynamic links, but it tracks the lexical scopes instead of the dynamic scopes. And so then you can associate these chain offset and local offset pairs with each variable. And you can read in the textbook about how all this works, but these are all sort of the details about how the static scoping would be implemented if you had nested subprograms. We should also talk a little bit about dynamic scoping. So again, we said that dynamic scoping isn't really used a lot, but if you do need dynamic scoping, then you need to be able to look up variables by the activation records that are on the stack. And so you need a way of looking through those activation records. And so, one approach that's pretty obvious is to just look through those stack frames one by one and have everything labeled on the stack. And so you just follow the base pointers or the dynamic links, and you just search one activation record at a time. So this means that you're going to have slow access to variables because you have to do that linear search every time you're referencing a variable, but it's going to result in relatively fast linkage because you don't need to do anything special. You're already tracking the dynamic link anyway, and so you don't really need to do any extra work when calling and returning. Another approach is something called shallow access, where you maintain a stack for every variable name, and you sort of push and pop the different variables onto those stacks alongside of the regular activation record. So rather than just having one system stack, you basically have a single stack for every variable as well as the system stack. And so the advantage here is that the active copy, the variable that is in the most immediate dynamic scope, is always the one that is on the top of its corresponding stack, which means that access times are faster. In fact, they're O of 1 because you can just grab it off the top of the stack. However, you have to spend the extra time during calling and returning to set up these stacks. So there's a little bit of a trade-off here.